Firstly, just know that there are tools that you need to use to prove identities. Now, I've listed some of them here. One is to split left-hand side and the right-hand side. So you can't solve both simultaneously. You either solve the right-hand side or the left-hand side. Two is use the identities tan theta equals to sine theta over cos theta, and sine squared theta plus cos squared theta equals to 1. Now, I'm sure you are familiar with these identities. They are essentially the first identities you learn when you're learning about identities in trigonometry. 3, use compound and double angles formulae. 4, addition and subtractions. So you need to then find the LCD and simplify. So in cases where you have your fractions, that's where you need to find your lowest common denominator. So you also need to factorize. Take out the highest common factor, difference of the two squares, trinomials, grouping, sum of all differences of the two cubes. So let's carry on to the next part, where we do an actual example. Prove that sine 2 over 1 plus cos 2x is equals to 10x. Just note that when solving the right hand side in this case, your double angle for sine 2x will be 2 sine x cos x. Now your double angle for cos 2x at the bottom, you have 3 options. You need to go with 1 plus cos squared x minus sine squared x. So remember, you have 3 options. So that's the best alternative when proving this particular question. So you carry on, rewrite the top as is, 2 sine x cos x. You go to the bottom, you then multiply what's inside the bracket with what's out. So it's 1. So you'll have your minus sine squared x plus cos squared x. Now, at this point, you need to rewrite what's at the top. Your 2 sine x times cos x. Remember, at the bottom, you have that 1 minus sine squared x plus cos x, which becomes your 2 cos squared x. For more on that psychology, please comment on our comment section in our YouTube channel. Ensure that you ask the relevant questions. Now, your final solution for this will be your sine x over cos x. Now, we all know what sine x over cos x is, right? Sine x over cos x is equals to 10x. Therefore, this is equals to the right hand side. We are going to carry on to the next part of the question, where we have now sine 3x equals to, so prove that sine 3x is equals to 3 sine x minus 4 sine cubed x. So we carry right along. Solution for this will be, you look at the sides. The most complicated side seems like the right hand side, but we are going to still use the left hand side, where we are going to expand it. So sine 3x can be expanded to sine 2x plus x, which can further be expanded into equals to sine 2x by cos x plus cos 2x by sine x. So that's the complete expansion. And then now we are going to resolve by taking out the common factor, right? So 2 sine x cos x by cos x plus, now you have your 1 minus 2 sine squared x sine x. You then carry on to the next part of the question, where you go 2 sine x, so you're rewriting cos squared, where you have multiplied cos x by cos x to get cos squared x, plus your sine x. Now you have distributed that sine x into the bracket. Sine x minus 2 sine cubed x. You therefore carry on resolving. You write your 2 sine x. For your cos squared x plus sine squared x, it's 1. So you will then change that to 1, and you will remain with your sine x squared, and then you will have your plus sine x minus 2 sine cubed x. Remember, for more clarification, you can always reach us on our YouTube channel for this. So 2 sine x minus 2 sine cubed x plus 2 sine cubed x, right? And then you see the like terms. Now you just group the like terms. 2 plus 2, those two are equal, and then your 2 sine x plus sine x, it gives you 3 sine x. You therefore have found the answer, equals to the right hand side. If you are unsure about what we are doing, you are always welcome to comment on our comment section on our YouTube channel. Now we'll carry on and do the third one. Now this one is a fraction where it says prove 1 plus sine 2a all over cos 2a is all equals to cos a plus sine a cos a minus sine a. So that is cos a plus sine a over cos a minus cos a. So let's carry on with the solution here. Remember, you are always allowed to disagree by sending your comment through to our channel. We are happy to clarify things for you. For now, we will rewrite the left-hand side. After rewriting the left-hand side, we are going to expand it. So 1 plus 2 sine a cos a. Do you see the expansion? Double angle. So the cos 2a at the bottom, another expansion. This time we will use the double angle. For cos, you have 3 options. We'll use the cos squared a minus sine squared a. At the top, we still have your cos 2 cos squared a plus sine squared a. You see where that comes from. The 1 has been converted to cos squared a plus sine squared a, because you can interchange, and then you rewrite the 2 sine a cos squared a. At the bottom, you keep it the same, cos squared a minus sine squared a. Now what you are going to do is you are going to factorize. Factorize what's at the top. Firstly, just group them up so that they are not less confusing for you. So you can start off with cos squared a plus your 2 sine a cos a, and then you have your sine squared a all over cos squared a minus sine squared a. Like I said, this factorizes nicely at the top, and at the bottom it also factorizes nicely. So let's start factorizing. To factorize, you need brackets. So you'll have your brackets, 2 brackets at the top. So your first bracket will contain your cos a, right, plus sine a. So, and then you'll have another bracket which can contain a cos a plus sine a. You see the logic behind this, right? Let's carry on to the factorizing of the bottom of the group, which is your cos a. Again, minus this one is slightly different because the signs won't be the same. Cos a minus sine a, and you have your cos a plus sine a. And then you can simply cancel out the bottom with the like terms. Cancel. You therefore have your answer, which is equals to the right hand side. This is it for us for the day. And don't forget to subscribe to our channel, like this video, and always share with your friends. Ask relevant questions. Swearing is not allowed in this channel. Hopefully we have not left you confused, but if you need more clarity, just hit us up. Now here's an exercise that you can prove by yourself. So for this exercise, please look at the examples we've done. So everything that is here has been done in the previous examples. So this is the exercise. Remember, our follow-up video is going to be answering all these questions in this exercise. If any of these questions confuse you, remember, there's a video coming up for this particular exercise. So prove the following. Basically prove that the left-hand side is equals to the right-hand side. Now, you can't prove both of them. You need to prove either the left-hand side or the right-hand side. Thank you for watching.